Well, that is the issue. The James Webb Space Telescope is disturbing the apple cart out of nowhere. We understand that we may need to change every one of the course books about the start of the universe now. It requires a long time to make a world like the Milky Way. Our insight into the universe grows a great deal every year as researchers all over the world make astonishing revelations that change what we realize today. We're going to discuss probably the freshest and less notable finds, ones that, indeed, even the most experienced specialists can't sort out. Join us as we explore the profundities of space and track down mysteries that assist us with drawing nearer to tackling some of the main inquiries in the universe. We'll take a gander at odd exoplanets that could defy the guidelines of physical science and the odd infinite events that nobody has had the option to make sense of. Imagine that a planet was seen in the external portions of our nearby planetary group that follows its star in reverse, contrasted with other planets. Not only would such a find be interesting, but it would also call into question current ideas about how planetary frameworks form. Analysts have as of late discovered some of these bizarre exoplanets. For instance, some circle their stars in extremely close orbits, which makes the surface exceptionally hot and ready to melt metals. Others are maverick planets that wander through the universe without a star. This raises questions about where they came from and how they stay alive in the harsh climate of space. Understanding the intricacies of these puzzling celestial bodies greatly expands the field of astronomy. This has impacts on both academic interest and practical issues, such as how we may live on different worlds in the future. Each new finding is a vital piece in putting the huge riddle of the universe together. Contemplate what it would mean to find water vapor on a distant world or to discover a planet with an atmosphere like Earth's. These results could indicate where conditions are suitable for life to begin, which could assist in planning future trips to these distant places. Figuring out the remarkable shapes and behaviors of these planets also helps researchers improve their models of the construction and development of the universe. This gives us clues about the past and fate of Earth. Imagine if we find an exoplanet whose orbit isn't smooth, which conflicts with current hypotheses of gravity and makes us question what we assume we know about physical science and how things move in space. Not only is this somewhat valuable information for school, but it will also affect technology and space research. The discovery of 2007 or 10, the largest world in our nearby planetary group that hasn't been named yet, is a fascinating case study in how to find and study celestial bodies. This faraway object, which is in the scattered disk region beyond Neptune, presents astronomers with both new challenges and opportunities. Cosmologists found 2007 or 10 for the first time while utilizing the Samuel Oskin telescope at Palomar Observatory during a routine check. It was confirmed to have been found by examining predating images made by the Spacewatch project. This illustrates how space science is often collaborative and akin to a detective story. 2007 or 10 is the third largest known dwarf planet in our solar system, with a diameter of about 1,535 kilometers, making it an exceptionally large planet. Despite its size, it doesn't have a name yet because we don't fully understand its orbit and haven't been able to sort it out to the point of meeting the International Astronomical Union standards for naming objects. Its surface is bafflingly dim and red, which suggests that it contains complex organic compounds called tholins. These are formed when sunlight hits simple organic compounds like methane and ammonia. Did you know that despite its enormous size, 2007 or 10 remains unnamed because its orbit has not been determined with enough precision to allow it a formal name? Its dark surface and slow rotation make it one of the solar system's most elusive objects. The investigation of 2007 or 10 includes both direct observations and computer models that attempt to figure its orbit and determine what its actual properties are. To gather data, space experts utilize both ground-based telescopes and space platforms, such as the Hubble Space Telescope. The light curves from these observations help us decipher its unusually slow rotation period. It takes around 45 hours to complete one rotation, making it one of the Kuiper Belt objects that rotates the slowest. When you thought we knew everything there was to know about our solar system, discoveries like 2007 or 10 come along to challenge our perspectives. But hold on, What we find next about another far-off celestial body may very well rethink the incomprehensible. This introduction to 2007 or 10 not only opens the door to a deeper investigation of unusual celestial bodies but also demonstrates how we are still discovering new things in the outer solar system. Each piece of information we gather helps us learn more about these distant worlds and the universe overall. Ultra-hot Neptunes are an intriguing group of extrasolar planets that don't behave like typical planets. These objects in space orbit exceptionally close to their stars, much closer than Mercury does to our Sun. This proximity can cause their surfaces to become extremely hot, over 17 degrees Celsius (392 degrees Fahrenheit). Being so close to their host stars challenges what we think we know about how planets form and how they can survive, as it can lead to atmospheric blow-off, which is when the atmosphere is literally torn away by the radiation and winds of the star. To give you an example, consider Kelt 9b, an extremely hot Neptune that is so hot that molecules like water can't form and instead break down into atomic hydrogen. Observing these planets not only tests our knowledge of climates but also how well our existing models of planetary grouping hold up. Extreme conditions raise significant questions about the diversity and stability of planetary systems around the world. If you compare ultra-hot Neptunes to other types of planets, what do you think the reasons for their scarcity might be? Could it have something to do with how they formed and the conditions that must be met to create such harsh environments? Let us know your thoughts in the comments. Are you intrigued by the secrets of 2007 or 10? Just wait until you learn about AYS 134834. What researchers found around this extremely massive star could be the key to understanding how celestial monsters form. This transition from discussing ultra-hot Neptunes to discussing AYS 134834 suggests that we will continue to explore the weirdest and most extreme phenomena in the universe. Every topic builds on the previous one, focusing on new revelations and surprises that keep occurring in science and make us question what we think we know. AYS 134834 is an extremely massive star in the deep regions of the galaxy Centaurus. A new investigation of this star has shed new light on how complicated star formation is. This gigantic astronomical body, which is about 1.3 times the mass of our Sun, has called into question the possibility that enormous stars are typically made when more modest stars collide with and converge with one another. Rather, the finding of a huge plate of gas and residue circling AIS 134834 proposes that even the greatest stars could shape similarly to how more modest stars do, by leisurely assembling matter from a protoplanetary disk. Such an outcome has vital impacts. It's not only a level component. The plate around AYS 134834 is moving and brimming with complex organic atoms and residue particles that cooperate with one another as the star's gravity arranges them. Even in these unforgiving circumstances, this interaction could lead to planet formation, which could imply that researchers can search in more places for new worlds and perhaps life. Space experts can work on their models of how stars develop and change over time by studying the distinct properties surrounding AYS 134834. Its number, splendor, and the gravitational draw of its mass make it a remarkable spot to study how matter behaves in some of the system's most lively regions. This study is very significant for both outlining the life cycle of stars and investigating the plausibility of planets forming in places that were believed to be excessively antagonistic before. Our next point is rogue planets, which incorporates both the intriguing conditions of large stars like AYS 134834 and the mysterious planets that wander the universe. These secretive bodies, which float in space without a star to circle around, make us contemplate what a planet is and where they can reside. Rogue planets are both baffling and educational. They represent a new frontier in our quest for knowledge about the cosmos. Quick inquiry. What do you think would happen to a planet that isn't held in place by the gravity of a star? We'll find out with our next subject, which is rogue worlds. We move from discussing enormous star systems like AYS 134834 to discussing rogue planets. This is one of the most intriguing subjects in cosmology. These are celestial objects that float through space without being pulled by any star. They are also called rogue planets or free-floating planets. This is altogether different from the regular thought of planets as objects that circle stars in a recognizable planetary system. These peculiar space explorers aren't kept down by the gravity of any star, so they travel through the sky on their own. Their discovery conflicts with the standard notions regarding how planets form, which state that the gravitational pull of a star is essential to assemble and shape planetary bodies. Rogue planets are believed to form in one of two ways. Either they are tossed out of their home planetary systems by gravitational forces, or they form on their own in a nebula of stars that are still developing but never come together with a star. Rogue planets are particularly hard to find, and methods like microlensing are often used to detect them from Earth. This occurs when the rogue planet momentarily shines brighter than a distant star as it passes in front of it. These events are rare but provide helpful opportunities to delve deeper into the features of these wandering planets. Their existence has immense effects on our understanding of the universe. They show that planetary systems might be more complex and dynamic than we previously thought, and that the right conditions for planet formation can occur in more scenarios than just those where planets circle stars. Additionally, the sheer number of these planets, potentially more than the stars in our own universe, points to a tremendous hidden population that challenges our thoughts about how common and widespread planets are in the universe. It's conceivable that these rogue worlds are more common than stars, which raises intriguing inquiries about the possibility of life in these harsh environments. Might life exist under a thick layer of ice that is warmed by geothermal heat on a planet that is traveling through the cold void of space? The possibilities prompt us to think creatively and push us to find better ways to identify phenomena as we continue to explore space. Focusing on rogue planets not only helps us learn more about how planets form and how they can survive, but also opens up additional options in our quest for life beyond Earth. Now, let's direct our attention toward an intriguing area of astronomical study that gazes straight into how life started. Complex organic compounds have been found in the protoplanetary disks around young stars through recent studies. These particles, which are sometimes called the building blocks of life, are comprised of various carbon-based substances that are essential for life on Earth as we know it to begin. Protoplanetary disks are dense regions of gas and dust that form around newly formed stars. They are where planetary systems begin. Complex organic molecules have been observed in these settings that are continuously evolving. Atomic structural blocks like amino acids and simple sugars are created through chemical reactions accelerated by the youthful star's energy and various activities in the disk. The detection of these particles in protoplanetary disks is significant because it implies that the building blocks for life might be distributed across the universe within the disks that ultimately come together to form new planets. This suggests that the conditions required for life to begin occur very early on when stars and planets are being formed. You can imagine a protoplanetary disk as a colossal kitchen in space where different materials are combined to create a recipe. The disk blends gas, dust, and organic particles under the influence of stellar energy, similar to how a baker combines flour, sugar, and eggs to make a cake. This could lead to the development of planets that can support life. This enormous recipe sets the stage well before planets even completely form, which really means that if life begins to form on a planet, its essential building blocks were likely initiated very early in the life of its star. This discovery not only helps us learn more about where life could begin but also broadens the possible habitable zones to include a wider range of planetary settings. We no longer need to search exclusively for planets with life on them. Now we can contemplate how life could start in the space between the stars. The investigation of complex organic compounds in protoplanetary disks leads to new ways to search for life beyond Earth and raises fascinating questions about whether the building blocks of life are the same everywhere. The circumstances that could permit life to begin wherever in the universe, as we keep on concentrating on these grandiose homes, as we proceed with our Investigate the Bizarre, we should explore the peculiar things about Kepler-78b, a planet that apparently shouldn't exist in view of normal thoughts about how planets form. This extrasolar planet not only questions our scientific thoughts, but it also captivates our minds with features that are similar to Earth. It changes what we believe is possible in the universe. In 8.5 hours, Kepler-78b makes a round trip around its star, which is much closer than Mercury is to our Sun. Because they are so close, the surfaces are extremely hot and wouldn't be really good for life as far as we might be concerned. The thing that really confuses people is that its composition and mass seem to be Earth's. This makes it appear that Kepler-78b is a rocky planet with a big iron core. This leads me to wonder how such a body could have formed so close to its star without being destroyed. The fact that Kepler-78b exists changes our opinion on how planets form. According to the most recent models, planets are believed to form in the cooler outer regions of a star's protoplanetary disk. They might move inward, but not quite as close as Kepler-78b. Its discoveries suggest that there might be unknown processes at work that can create rocky planets in circumstances that were believed to be impossible before. Even though Kepler-78b is in a harsh environment, its composition makes it seem like it very well could be related to Earth since the two planets have a similar structure. This similarity has significant implications for the investigation of exoplanets, as it means that Earth-like worlds could exist in a variety of orbits, some of which we haven't even considered. Imagine a planet that doesn't belong in the universe but is still turning through the stars, regardless of our best efforts to make sense of it. As we come to the end of our journey through the universe's most baffling parts, we should contemplate how these new finds may fundamentally alter the manner in which we investigate from now on. This reflection paves the way for the end of our exploration and stresses how significant these outcomes are for widening our perspectives and pushing the limits of what we think is possible in science. Imagine you are a scientist investigating Kepler-78b. What sorts of studies do you think should be done to figure out more about this strange planet? Leave your thoughts below. As our journey through space continues, we move from the baffling Kepler-78b to the intriguing world of white dwarf stars. White dwarfs are some of the coolest things in space that are classified as stars. They help us learn more about the universe by connecting the features of these coldest stars with those of gas giant worlds. White dwarfs are a type of brown dwarf. Brown dwarfs are objects that are not stars but are in the mass range between the biggest gas giants and the smallest stars. These brown dwarfs don't have enough mass to start hydrogen fusion, which gives real stars their power. Why brown dwarfs are particularly interesting is because their temperatures are extremely low. They can be as cool as room temperature, which is around 25 degrees Celsius, 77 degrees Fahrenheit. In contrast, the surface of our Sun is around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. The discovery of brown dwarfs questions the traditional ways of categorizing celestial bodies. Our understanding of what a star is has evolved since their discovery, primarily through infrared surveys like those done by the Wide Field Infrared Survey Explorer (WISE) telescope. This has implications for understanding atmospheric compositions in a broader range of conditions than we previously thought possible. Researchers can study the atmospheres of white dwarfs that are cool enough to have water clouds and other complex chemical compounds that are typically found on planets, not stars. Due to how they are formed, this unique characteristic provides us with information about both stellar and planetary processes, blurring the lines between the two groups and helping us learn more about phenomena that occur in space. The investigation of brown dwarfs not only helps us understand how stars develop and what their properties are, but it also aids us in finding places where life may be possible, even in locations we wouldn't expect. As these objects get closer together, the line between planet and star becomes less distinct. This makes us ponder where life could develop or already exist. In conclusion, white dwarfs illustrate how unique and diverse the universe is. They entrance us and help us get more familiar with it. They reveal to us that the universe is a colossal and astounding place filled with things that don't fit into any simple categories, continuously pushing the limits of what we think we know. This exploration of brown dwarfs sets the tone for our final reflections, which are filled with wonder and amazement at the complexity of the cosmos we are striving to comprehend. We have now reached the end of our journey through some of the most strange and intriguing parts of the universe. We have seen rogue planets floating without a star, looked at the complex organic molecules and protoplanetary disks that may contain the building blocks of life, marveled at the puzzling properties of Kepler-78b, and dove deep into the cold yet captivating universe of white dwarfs. All these topics compel us to think and stretch the boundaries of what we know, demonstrating how unique and complicated our universe is. The discoveries we've discussed today, such as planets that don't fit our current models of planetary science and the possibility of life in places we didn't anticipate, show how mysterious and intriguing space exploration is. These findings illustrate not only how vast the unknown is but also how many astonishing things we could discover in the future. Feel free to leave your thoughts and reflections in the comments below. What did you find most fascinating about today's exploration? Do you have any thoughts or speculations about these odd occurrences in space? Join the discussion and be a part of this exciting journey of discovery. Remember to subscribe to see more videos like this one. Each new thing we find in space tells us something significant about the universe and our place in it. The things that drive us forward are your curiosity and desire to uncover these cosmic secrets. Thank you for watching, and remember to keep looking up. You never know what secrets the next night sky could hold.